Some of the new features in Softimage 2014 include big improvements to the behavior tree of CrowdFX. Here I wanted to share a scene with you that shows three different actors working together in the same scene. If we have a look at our simulation tree, what I would like to first of all show you is that we can define actors as having different IDs. If I look at the emit branch of the tree, you can see that I've got a little branch here that takes my emitter ID. So in essence, it's taking the emitter that I've got here. And if you look at that emitter, look at it in an ice tree, it's initialized with an ID of 1. And the second emitter has got an ID of 0. So we're using those IDs to drive the select case node, which defines the actor ID to use. So actor ID, crowd emitter ID 0 will yield an actor ID of 0, and my marine characters are set, the soldiers here are set to use actor ID 0, while the remaining crowd members, which is case 1, which would correspond with emitter 1, are going to use actor IDs 1 and 2. And of course, if I visualize that, we can see exactly that. So we have actors of ID 0 and actors of ID 1 and 2. I've also used the crowd emitter IDs to define social groups. Social groups are, again, just another way of helping to break up the scenes or the characters in your scenes so that you can give them different interactions or assign different actions to characters of different social groups. Initially, in this incarnation of CrowdFX, the social group index is used so that characters within the same social group don't necessarily try to avoid one another. In any event, if we have a look at the behavior tree, this is where a lot of the improvements in logic have occurred. So the heart of the behavior tree now is what's called the behavior core. And the behavior core is broken down into 3 sections. First is the simulation core, where you define all of the logic. Initially, what you're going to be doing here is defining your basic crowd simulation, which is defined by velocity and direction, or using a simple collision avoidance solver. We'll talk a little bit about how this is blending in just a moment. The second part of the behavior core is the post-simulation graph, which is usually used for defining your interactions with scene objects. So if you have uneven terrain and you want your character's feet to stick to the ground, you can use the new stick to ground node to help simulate that. And of course, avoiding any obstacles and walls that your character might find in his or her way, or its way, I guess you could say. And finally, you've got the animation state portion of the behavior core. And if we look down at the animation state, this is just a little bit of logic here using the new set animation state node. If I was just to unplug that for the moment, on its own, it allows you to set any animation state that's available to you in your animation definitions. So if I look at my animation definitions here, you can see that I've defined a number of states. Of course, I've defined my marine model as having an idle state. I've also got it as defining a move state, and the same goes for each of the pedestrian characters as well. Eric has an idle state as well as a move state, and so does the Eliza character, idle state, and a move state. So the states for the characters are all pulling in different action presets, but they're all being referred to in CrowdFX as the same name. Of course, I need transitions between the idle states and the move states, so I've got a define animation state transition to take care of that. And it's a bidirectional state transition from idle to move and back the other way. So jumping back into our behavior tree, as I mentioned, this animation state allows us to actually implement the states themselves using the logic we define up here in the simulation portion of the blending core, or of the behavior core. So what I've got here is a simple state transition, or a state moving between state 1 and 2 here, or between my move and my idle state, based on a comparison of the current actor's target speed and whether or not it's greater than 0.1. So if we have a look at the basic crowd simulation, we're doing a couple of things here. So first, what I'm doing is, if the character's particle velocity, so if their current speed is less than 0.1, it means they are going to be entering an idle state. And entering into the idle state will trigger this branch of your behavior core. So this is basically setting our speed and direction to 0. And of course, that would trigger an idle state down here. I'm using the animation state selector nodes to pick the state that I wish to use. If, however, my particle velocity isn't equal to 0, I then want to solve for collision avoidance. And in this case, I want to use the set goal by walls compound to avoid any walls that my character might find in his or her way. If we have a look at my scene here, I've got my walls in a group. They're already hidden. Now, the setting the walls is very similar to what you may have done in Softimage 2013. So I've got my walls in here, and my characters are set to avoid them. And of course, they're using these little exit point nulls here to help, further refine where the characters try to avoid those walls. And so I've got vehicles that are surrounded by 4 walls with exit points on all 4 sides. Keep getting this nice performance slowdown here. CrowdFX is a bit heavy on my system with Camtasia, so I'm clicking away. In any event, let's come back into the ice graph. So what I want to do is then set a couple of different goals on my collision avoidance, or setting goal sequencer, the walls as I've just mentioned, and using the set goal from direction. And from here, we can start to trigger our speed. There we go. It's going to be a little bit better. So our speed is based off of a couple of different conditions here. So what we want to do is, I've got a branch up at the top here that's just being executed. And what it's doing is it's helping me to break up my characters into good guys and bad guys. So what I've got here is a little branch that helps to define the positions of the characters in actor ID 1. I'm getting my actor ID. If it's equal to actor ID 0, which are the bad guys, build an array out of that and get the point positions from that array. And then what I'm going to be doing is I'm just comparing the actors of IDs 1 and 2 to the soldiers' positions. So I've initialized a value here called set soldiers' positions. This is actually thanks to Graham off of the mailing list. He helped me sort this portion of the branch out. And we'll get the length off of that. And essentially what this is saying here is we're measuring the distance to the soldiers. So we're getting the length off of that comparison, finding the minimum length of each of the actors in ID 1 and 2 to the soldiers, and taking that minimum value. And again, we don't want to deal with this if we're only comparing these values if we're working with actors 1 and 2. So we're basically ignoring the soldiers in this portion of the branch. And if the actors in ID 1 and 2 are less than the threshold, so they're less than my threshold here, which I've set to 64 units away, then what we do is we set a Boolean flag called speed up. So we tend to use that branch in our logic here. So our speed is largely going to be defined by a combination of things. We're checking whether or not our particle velocity is less than 0.1, and as long as the characters are not flagged to speed up, then yeah, the characters can hang out in their idle states. We set their velocity to idle, and that would of course pick from the action defined by the idle state per actor. If, however, this is false, then we're going to run a second branch here. So what I want to do is I want to get the actors of ID 0, and I want to give them a faster speed, something between a walk or a slow and a fast move, a run. So these would be essentially a move state. If the characters aren't actor ID 0, so if they aren't the bad guys, then what I want to do is run a linear interpolation to blend the current actor speed into a speed up state. Essentially, we want to have these characters run away from the soldiers. So we want to increase their speed to something like 60 or 80 units per second. blended off of their actor speed. And the way that we're doing that to get a nice transition is we're using a distance to soldiers, so getting that value that we set earlier on in our branch, and basically just rescaling it so that the closer the soldiers get, the closer to 1 the blend value gets, and that's what's helping define our transition. So the further the soldiers get away, characters kind of calm down a little bit, and they're not quite so nervous. And the last part to this as well is we're running this branch as long as the actor ID is greater than 0. So as long as it's anything but the soldiers and the speed up flag is equal to true, then we're going to run the blend between distance here. So that's essentially all that is. Again, it's just one way of handling the behavior core and the logic in it. And let's have a look at the scene. So again, if I'll just hide my walls, I'll hit play, and what you'll notice here as we play is that as the soldiers get closer to the actors, they will get a bit nervous and they will tend to speed up. So we'll let this simulate for a little while. So the soldiers are kind of on patrol. I hope they're not on parole. And so you can see that some of these pedestrians aren't overly concerned right now, but as they start getting soldiers start getting a little bit closer, actually they will start to get a little nervous and they will speed up. So basically what will happen is this will always keep the characters in front of the soldiers. So they're kind of hurting them, I guess you could say. So you can see Eliza here at the back. I guess there's a bunch of these Elizas starting to speed up a little bit. These characters here are starting to speed up a little bit. They just don't want to stay too close to these soldiers, and who could blame them with these rifles pointed at them. So the characters are speeding up a bit. Some of the characters that are over on the side here are a little bit lucky, but even he's a little bit nervous and he's starting to speed up a little bit as well. So again, this is a very useful way, of course, of creating custom behaviors, and you can mix and match them with other custom behaviors that you built. It really is a robust system. So that's one example of how the behavior tree has been improved in Softimage 2014.